All right, this problem separates the men from the boys. This is the toughie because it's a little bit weird. We have water being pumped into a conical storage tank, which is right here, um, at 2 cubic feet per minute. Let d of t be the depth of water after t minutes. Find d of t. And then we know the volume of a circular cone of radius r and height h is pi r squared h over 3, or 1/3 pi r squared h. So now, the reason why this is tricky is because since this is a cone, if I pour this in at a constant rate, the height isn't going to raise at a constant rate, which is a little bit different than the cylinder we did before, because the cylinder increased at a constant rate. So we need to take that into consideration when we're solving this problem. So let's see if we can draw this for a second. If we draw the water in here, this right here is going to be the radius of my water, and this is going to be the depth of my water. So this is r, this is d. So let's write what we know with some equations that we can generate. So first of all, we know that the volume that's going to get pumped in is going to be the rate times however long you pump it in there. So that's going to give me my volume. So I know the volume equals 2 cubic feet per minute times however many minutes we put it in there. That will give me my volume. Another volume equation I know, which is given here, is volume equals pi r squared h, which in this case is going to be my d. So I'm just going to put d all over 3. So those are my two equations. Now the problem is I have too many variables. Too many variables here. So I have t, I have the radius, which changes, and I have my depth, which also changes. But one thing I do notice is I have two triangles here. I have this triangle right here, and I also have, let's see, this triangle right there. And what do I know about those two triangles, you ask? They're similar, right? Since they're similar, I can set up a proportion. So I have 3/8 equals r over d. So again, if I look over here at these equations right here, I'm going to solve this equation for r. Because I have d and t in this equation, I don't have r as any part of my function. It's just the radius, and the radius changes as the volume changes. So I'm going to solve this for d, or sorry, solve this for r, multiply both sides by d. So I have 3d over 8 is equal to my radius. So because it's proportional, I can substitute this radius into my volume equation. So I'm going to have my volume equals pi times my radius, which I said was 3d over 8 squared times d all over 3. So again, I know I have this volume here, and I have this volume here. Let's set those equal to each other now. So I have 2t equals, let me simplify this a little bit. So that's going to give me, since I'm dividing this by 3 over here, it's like multiplying it times 1/3. So I'm going to have 9d cubed over 64, and then this is times 1/3 because it's divided by 3. If I look at my function here, I'm trying to find d of t. So remember, since I'm finding d of t, I'm going to be solving this for d. So whatever is on the outside here, that's what I'm going to solve for. That's the one I'm going to isolate, because the function is going to be t. So I'm going to need that variable in my equation. So I'm going to solve this for d. So I'm going to make my life easy. I'm not going to multiply 3 times 64, so I'm not going to need to use a calculator. So I have 3 times 2 on this side, so I'm going to get 6t equals 9 times d3. Oops, I forgot my pi. Pi over 64. So now I'm going to multiply by 64, divide by 9 pi. So I'm going to multiply by the reciprocal. This is going to be easiest way. 9 pi. And then this side, 64, 9 pi. So this cancels, that goes to 2, this goes to 3. So then I get 128t over 3 pi equals d cubed. So I take the cube root, both sides. So my function then is d of t equals the cube root of 128t over 3 pi. It's yucky, but it works. If I substitute, again, 3t is just a number. T is my is how much time I have. So my depth is going to be changing in terms of the amount of time I take to pour it in there. So again, you want to check to make sure it makes sense. Try a value, see if it makes sense after a certain period of time. All right, nice work.